Hey folks, this is Mr. Woodward. In this video, we're going to talk about inertia and what happens when it's difficult to overcome inertia in real life. This is Newton's first law of motion. So first of all, what is inertia? Inertia comes from the Latin word iners, meaning idle or sluggish, right? Think of something that's difficult to move. Something's idle or sluggish, won't get off the couch, won't move, won't get started. Inertia is the resistance of an object to any change in its velocity. You could also say inertia is the resistance of an object to an acceleration. This includes changes to the object's speed or its direction of motion. Typically, physicists describe this as the tendency of objects to keep moving in a straight line at constant speed when no forces act upon them. Okay? So hold that in your mind as I go through this presentation. The tendency of objects to keep moving in a straight line at constant speed, that is inertia. Isaac Newton defined inertia as the first of his very famous 3 laws of motion in his Principia, published in 1687. And the language that he used for this first law of motion, the law of inertia, was the vis inertia, or the innate force of matter, is a power of resisting by which every body, as much as in it lies, endeavors to preserve its present state, right? That's that sluggishness, that idleness, whether it be of rest or of moving uniformly forward in a straight line, okay? So objects want to keep doing what they're doing. They don't want to accelerate. They want to maintain their motion. Have you ever unsuccessfully tried to move something heavy like a piano, or worse, try to stop something heavy from falling or rolling away? Maybe you even got hurt in the process. When we cannot overcome inertia, right, this tendency for an object to resist an acceleration, the results can be surprising, hilarious, embarrassing, or even destructive. And so I'm going to show you a number of examples here of overcoming inertia in these sort of silly or ridiculous ways. And in part 1, we're going to look at struggles to overcome this resting inertia, right? The tendency of an object that is at rest to remain at rest if there are no outside forces. So the tendency of an object to resist accelerating out of rest. So here's a Cadillac on a tow truck that is initially at rest, and the tow truck driver forgot to strap it down, right? And so the Cadillac isn't going to just magically follow the tow truck unless there's some outside force. And so what I've written on the rest is on the left is a Cadillac at rest remains at rest unless it's acted on by friction from a tow truck bed or maybe tension from the tow truck straps. Either way, it's a bummer. This car is going to suffer some major damage from falling off of the bed of this car. Here's the tablecloth trick. Okay, if you can whip a tablecloth out from something quickly enough, the dishes or whatever object are on the table will stay at rest, because in this case, a glass at rest remains at rest unless it's acted on by friction from a tablecloth, and silky tablecloths work best for this. Okay, the objects on the table want to resist acceleration. Here's a toilet paper pull. Right, if you want to snap off a roll of toilet paper without pulling out the whole roll, you've got to do it quickly, right? If you pull too slowly, you're going to unroll a bunch of toilet paper all over the bathroom floor. That's because a roll of toilet paper at rest remains at rest unless it's acted on by an applied force from someone's hands, okay? And by the way, this is a particular kind of inertia called rotational inertia. So this is an example of an object that wants to resist rotating. Here's a classic shopping cart accident, and we'll see if this GIF restarts. So here's a couple workers at Target who have just finished loading all of the shopping carts in the back of the truck, and they forgot to close the gate, the rear gate. And so what do those shopping carts want to do? They want to remain at rest. Looks like maybe there was enough friction for the shopping carts on the far left of the truck. But this is because all these shopping carts, they're so massive, they have so much inertia, they don't want to accelerate with the truck. And so they don't. A shopping cart at rest remains at rest unless it's acted on by a normal force from a truck gate. Okay, that's the only way to bring those shopping carts into an acceleration from rest. And then here's another one, the hoop penning bottle trick.
Go.
So in this case, you've got, and I can play that one again because it was probably difficult to see. You've got this pen sitting on top of an embroidery hoop. And so it wants to remain at rest, but if you remove the normal force underneath it because of the embroidery hoop, it's going to accelerate down. A pen at rest remains at rest unless acted on by an unbalanced force of gravity. And here's our magic block of wood. If you notice, the man is hammering this wooden pole downwards, and yet it looks like the block of wood is creeping upwards. That's because the block of wood wants to remain at rest where it is, and every time he hammers down, he's sliding the pole deeper and deeper below the wooden block. A block of wood at rest remains at rest unless it's acted on by enough friction from the wooden pole. Okay, so that was all sort of examples of inertia at rest, right? But what about if something is already moving? Well, Newton's first law is going to say that an object will want to continue moving in a straight line at constant speed, right? That would be resisting an acceleration, to continue moving in a straight line at constant speed. Let's see some examples of this. So here's a car that is on a very icy road where there is not enough friction to bring this thing to rest. It wants to keep moving at a straight line and constant speed. So a car in motion remains in motion unless it's acted on by friction with the road. And they got lucky in this one. Almost hit that other parked car. Or here, we've got a skier who's going over a jump who sees another skier and boom, nails him. There's nothing she can do while she's in the air. No amount of swimming or trying to move over to the side. There's nothing that she can do to bring herself out of her inertia, right? She's going to move forward unless she finally hits something. A flying skier in motion remains in motion unless acted on by, in this case, a normal force from another skier. And this is why we wear seat belts. So here's a crash test dummy who's not wearing a seatbelt, whose head hits the windshield and breaks the glass. A dummy in motion remains in motion unless it's acted on by a normal force from an airbag. And so now here's the example where we've got the airbag, which is protecting the dummy from its own tendency to move forward in a straight line at constant speed. So here's with and without, right? In one case, your head goes through the windshield. In the other case, you're protected by an airbag, okay? If you're not strapped into that car, when the car stops, your body will continue moving forward. Law of inertia. Here's a water slide accident. We've got a boy who's way too big for this slide, coming in fast, and he just rolls right over the barrier and flops onto the ground at the end, okay? He's got a lot of inertia. That slippery, wet water slide does not provide sufficient friction to slow him down, and when he hits that barrier, he just plows right through it. Okay, a buoy in motion remains in motion unless acted on by a normal force from an inflatable barrier. And then I will leave you with this one. You'll learn about what happens to a raw egg's yolk as it spins. So a yolk in motion is going to remain in motion unless it's acted on by friction with the shell.
Most people know that if you try to spin a boiled egg, it'll spin nicely. And when you try to spin a raw egg, it'll be a bit more wobbly. But there's a cool trick you can do where if you spin a raw egg and then you stop it, the raw egg will start spinning again. What's going on? Why does it keep spinning? Well, it's because of something pretty important to physics, which is called inertia. Inertia is the property that all objects have, which keeps them doing what they're doing. So when you get the egg spinning, the yolk inside is spinning as well. And if you stop it from the outside, if you stop the shell, the yolk keeps spinning inside. So it'll get the egg spinning again without you having to touch it. Whereas with a hard-boiled egg, because the thing is solid inside, because the egg is solid, as soon as you stop the shell, you stop the whole egg, and there is no more inertia to keep the egg spinning.
And by the way, that is another example of rotational inertia, right? The tendency of a rotating object to keep rotating in this case, or in the example of the toilet paper roll, which is an object that's at rest to resist rotation. All right, Newton's law of inertia. Thanks for watching.